Okay, so this example is going to, we're actually going to write a linear equation from a word problem. So this is the speed on a hill problem. Assume that the maximum speed your car will go varies linearly with the steepness of the hill it is climbing or descending. For example, if the hill is 5 degrees up, your car can go 77 kilometers per hour. If the hill is 2 degrees down, or -2, your car can go 154 kilometers per hour. The first thing we have to do is identify our independent and dependent variables. It's important to keep in mind, sometimes that information is given to you. For instance, here, we're told varies linearly with. Whatever comes before that is your dependent variable, and whatever comes after it is your independent variable. But it's not always written so nicely for us. It might also say speed depends on steepness, and then that same thing is true. Whatever comes before the word depends on is your dependent variable, and whatever comes after it is your independent variable. But again, it's not always given to you in such a nice way. So, a thing to keep in mind when you're working with dependent and independent variables is the dependent variable is the one that changes because of the independent variable. For instance, the amount of gas you have in your car changes because you drove somewhere. So the gallons of gas would be the dependent variable, and the number of miles you've driven or the amount of time you've been driving would be your independent variable in a case like that. Okay, so our independent variable is also represented by x, unless you want to give it a meaningful letter. So x will be our independent variable, which is going to be the steepness of the hill, and y is going to be speed. So now we need to find slope and interpret its meaning. So you have to be able to tell me what slope means. So we need two ordered pairs in order to find our slope. So 5 degrees up, that's my steepness. My car can go 77 kilometers per hour, that's the speed that goes with it. Or 2 degrees down, -2. 154 kilometers per hour. All right, so now let's find our slope. On the top, we have the difference in the x's over the difference in the y's. And so that comes out to -11 for our slope. Now, we also need to interpret its meaning. And so remember that the top, my y variable, describes the speed, and then the bottom describes the steepness. So this -11 is like -11 over 1. And so that tells me that there will be a decrease of, that negative is the decrease, 11 kilometers per hour for every 1 degree increase of steepness. And so now we want to write the linear function for this. So remember, I like point slope form. Y minus y1 equals m times x minus x1. So that's y minus, you can pick either one of these two ordered pairs. I'm going to choose the first one. So y minus 77 equals -11, my slope, times x minus 5. And so now I'm going to distribute. And then I'm going to add 77 to both sides. Y equals negative 11x plus 132. That's my linear equation. So how fast can you go on a 7-degree downhill? Remember, x represents the steepness. Downhill means it's going to be negative. So y equals negative 11 times negative 7 plus 132. So y equals 77 plus 132. So you can go 209 kilometers per hour on a 7-degree downhill. Now the speed intercept, remember that speed was represented by y, so I want the y-intercept. That means I'm going to put 0 in for x and solve for y. And so that's 132 kilometers per hour. And what that means is, because we have to say what it represents the speed of the car with 0-degree incline. Right, we put 0 in for x, and x is our steepness, so no steepness means that you can go, is 0 for x, and you can go 102 kilometers per hour according to this function. If your top speed is 99 kilometers per hour, how steep is the hill? Is it up or down? And justify your answer. So 99 equals negative 11x plus 132. Notice I put 99 in for y. That's our y is our variable that represents speed. So we have negative 33 equals negative 11x. So x is equal to 3 degrees, and it's uphill, and I can tell because my answer ended up being positive. I will take math as justification for what you've got there. And then finally, what does the steepness intercept equal, and what does it represent? So steepness is x, so we want to know what does the x-intercept equal and what does it represent. So if I put 0 in for y, so what this means is that with 12 degrees of steepness, your car is not going to go anywhere. You'll have 0 speed.